Okay, thank you, Goran. So I also make it short. Just a little bit news story. It's actually literally a new startup here in Berlin. You probably haven't heard of us. And even so, we are high up above Berlin and everyone can see us up here, fairly new. So just a few words. So we are doing a mobile-first e-commerce platform, really rethinking about e-commerce for the mobile age. And that's all about, I say, about the company. If you want to know more about it, you can later pick me and I'm happy to talk a little bit more what we are doing. And as Goran said, it's a new series of like tech talks. We want to do it every month. And it's really something where we also want to connect here to the community, also want to share our knowledge here with the Berlin community. And I think all of us are really excited to have here, to be here in Berlin with so many people. So, but now to the talk. I would like to welcome Anders Bjørnestad. I hope I pronounced the name right.
Yeah, that's good.
And Anders is from Norway, and he has been working with Amazon Web Services for 5 years, always like in consulting companies. And he will really give us an overview what you can do with the Amazon Web Service, actually beyond just like really pushing something over there into the cloud. I think the Amazon Web Service have quite some fantastic feature that you can use to really launch a very robust application fairly quick. And I think what I'm really looking forward, he will also do some demos. I think that's always the exciting part of a talk, makes it less dry. And so I'm looking forward to that one. And maybe, Anders, you can talk a little bit more about yourself, what you talk about it.
Okay, guten Abend. Mein Deutsch ist nicht gut. Ich habe Deutsch gelernt, aber I will do this in English. I think it's the easiest part for everybody. I had German for like 4 years in school, but that was way back. So I can cope with getting beers and asking if there are any available rooms at the hotels and so, but when it comes to the computing part, it's better to do it in English. As it was said, I'm from Norway. I've been working with technology for after I graduated from the university there for almost 20 years ago. Worked a lot with, started working a lot with internet. Internet was quite new when I graduated from university. Moved into the Java community later when that became popular. And now I see the cloud is coming the same way as internet was a wave, and also the Java area where we had write once, run everywhere, and those kind of things, and getting things networked. So today, cloud computing, and we'll talk a little bit about elasticity in the cloud, and I'll use Amazon Web Services as an example on that, since that's the service I've been using most and have most experience with. I'm certified as a developer and architect on the AWS platform, and my company is also a consulting partner with Amazon, so we have quite good knowledge on the platform. But how about you guys? How many of you are running something on AWS today? Half, perhaps, of you. How many are developers? A bit more. And operations? And the rest are just managers or something like that, I guess. So I hope we can touch into some interesting topics. What I was thinking about today was just first say a few words about cloud computing in general. Why Amazon, why Azure, why the other infrastructure services. Then we need to understand the platform and the characteristics if we're going to look into the elasticity. Then looking at some demos, some examples about building application, a little bit about architecture, perhaps something about security. It's a bit up to you as well, and we have some Q&A at the end. And then it became dark for the movie filming man by there. But first, let's start with the definition of cloud computing. And there are a few people who really knows what cloud computing is, and there's a lot of people who is a bit scared if you're asked a question. Can you explain me what cloud computing really is? Right? You know, if you're getting into a discussion with some technical people or someone who is not really into IT, what is cloud computing really? And what you should have a quick look at is the definition from the National Institute of Technology. They have a definition on cloud computing and a standard on that. And it's not very big. This is all it is. So we really have time to read it. And what it basically says is that it consists of some characteristics, it consists of some delivery models, and it consists of a deployment model. Some of you may have seen that already. Know some of it. Broad network access, rapid elasticity, it's a measured service, and you have on-demand self-service if it's a cloud service. And the next thing is the delivery models. You have a software as a service, platform as a service, and you have infrastructure as a service. And then you have public cloud, private cloud, hybrid clouds, community clouds, and so on. And today we're going to look at some of the characteristics. We're going to look at the public cloud, going to look into infrastructure as a service. I think that's the most exciting part of this, because if you understand how the infrastructure cloud works, then it's easy to understand the others as well. Self-service we'll look into, and elasticity, as I mentioned. I just forgot to mention, if you have any specific questions, we'll try to take the questions at the end, because we're also filming. But if anything is very unclear, then please just stop me and have me clarify it. If we're looking into the separation of responsibilities, then we really need to understand, and it's important to understand, who is responsible for what parts of the cloud. And if you're looking at the left side here, you have the on-premises stack. If you're running on-prem, then you are responsible for absolutely everything. Application, infrastructure, hardware, software, networking, everything. If you're moving over to software as a service, then someone else is managing it. Like if you're using Gmail, then Google is taking care of everything. If you're moving to infrastructure as a service and platform as a service, then you have another split. And especially on the infrastructure as a service part, in general, you have responsibility of the operating system and everything above. And people tend to forget that. I have people starting up servers with Amazon, and they haven't patched them, because it's in the cloud. They think everything should just fix itself. But if you're running on Azure or on Amazon, you need to take care of your servers. You're responsible for the servers. You're responsible for setting up the security around your servers. You're responsible for patching your server. And that's an important distinction compared to platform as a service, where you're basically buying a runtime environment, like let's say you're buying a server with a Tomcat, and then you're just uploading your Java application, and then the service provider will update and patch that service for you. So looking into the infrastructure as a service, what should we say? All the businesses there and what they're trying to achieve. This is the Gartner quadrant with the standard, challengers, leaders, niche players, and visionaries in those squares. It might be a bit hard to see, but you can see the little blue dot up in the upper right corner. That's Amazon Web Services. And further down here is Microsoft. So those two are really the leaders now in the IaaS space. And if we're looking into the next slide, hopefully, there. Amazon Web Services is 10 times the computing size of the 14 other companies. So it's really huge. Microsoft is doing well. Google is quite low, but they're also focusing a lot on platform as a service offerings, and they're not so huge in infrastructure as a service. And then you have all the others which are struggling in the low left corner. So if you're wondering what to choose, then and you're building a regular application, then I think you should look into Amazon and Microsoft and really see what fits you, because there are differences between those two. But unless you have special needs, it might be risky to choose some of the others, and especially in Europe, because a lot of the others are only in the US and only have hosting in the US, and then you might run into problems with legislation and stuff like that. So that was a short intro about the cloud, infrastructure as a service, and partly where we're at. Then I'll move into why are people moving into the cloud. For those of you who haven't looked into like AWS or Azure, it's really, really quick to spin up servers in the cloud. You're talking about minutes, and it's regardless whether you want one server or you want 100 servers, compared to going to the IT department, filing a ticket, and then you have to wait 2 weeks to get your VMware instance. And of course, you have to have a project code, because it will cost you €1,000 as well to spin up that server or something like that. Infrastructure can be self-configurable. You only normally pay for what you use. So if you're using a server for 1 hour, you pay for 1 hour. If you're throwing it away after an hour, there's no more cost. That's something totally different than buying hardware. So also, when it comes to licenses, I often got questions about licenses. If you're using like Oracle, Microsoft SQL Server, stuff like that, in some cases you can bring your own license when you're running it on Amazon, or you can pay the license by the hour as well with a server or with a database, which is really cool. But really, people are talking about the cloud, and a lot of people think that the reason for choosing and going to the cloud is the economy. But when people start using it, they say that increased agility is the #1 reason to go to at least AWS. The two other reasons are security and economy. And there's really a shift now that people is moving to the cloud because of security, because they're seeing that Microsoft, Amazon, Google is making it so secure, so it's more secure than you can do it yourself. It's extremely costly to make it that secure, and it's also often more secure than even the banks are able to do it. But increased agility is important, and it ties into the elasticity and how we can use it later on, and we'll go into the examples and see that. Imagine, especially like for startups like Newstore and others, if you don't have to pay for any servers, you don't have to invest for any server in any servers, you can start it up, you can experiment, you can run a proof of concept, and you can throw it away, and well, maybe you have spent $5 or something like that on the experiment instead of buying some hardware. So increased agility, experiment a lot, fail immediately. If you have to throw the servers away, stuff like that is the reason for going into the cloud for a lot of companies. So just briefly about Amazon Web Services. They are, as I said, the definitive market leader in the IaaS area. They launched their first service in 2006. Started with some queuing services, then they had some compute services, some storage services. And they didn't do that because they had excess capacity. They did it basically because they made some cool services and they were trying to see if others were interested. They've had more than 45 price reductions since 2006. I think the latest number I saw was, I looked it up the other day, was 49 as of today. And just in 2015, they have launched more than 500 new features. So it's really moving fast and the prices are going down. So it's really hard for the old style IT to compete with that. Then if we're going to look into a bit more technical stuff here, we have to start digging into the Amazon cloud. And I've also put up a small logo in the left-hand corner on what's Amazon specific, because I have some general topics and I have something that's AWS specific. If we're looking at the Amazon cloud in this way, like we have the global infrastructure, we have a networking, we have compute, storage, and database services, we have some application services, and then we have some deployment and administration. That's one way to see all the different services AWS have. If we're starting now with the green box in the bottom there, that's the AWS infrastructure. And they are spread throughout 11 regions worldwide. And a region is 2 or more independent locations in one geographical area. So they're not in the same building, they're not in the same floodplain, but they're typically like 1 to 2 milliseconds apart, so you can do active syncing, for instance, if you're doing replicated databases. So that's a region. Within every region, they have a zone, so they have 28 zones. And as you can see, they're present in Europe. It's both in Dublin and in Frankfurt, so we can safely use it when it comes to the European legislation, data protection and things like that. Typically, size of a data center with AWS, I don't have the exact numbers because they're not disclosing all the secret details, but they talked about they had 102 terabit fibers into a data center, and a center contains typically of 50 to 80,000 physical servers. And one availability zone can contain several data centers. So we're really talking about huge operations. For example, they have 864 disks in a 19-inch rack. So they're building their own racks to fit a lot of disks in it. When you're talking about regions and availability zones, it's important to understand the concept because we're going to look into the flexibility of and elasticity of AWS and how we can make an application redundant. One region contains, as I said, of several availability zones. You have a region in Dublin from 2007, and you have a Frankfurt region in 2014. Dublin has 3 availability zones. Frankfurt have 2. So basically, you have 5 different locations you can spread your applications on in Europe or your data. You also have something called edge locations. That's point of presence where they are terminating their connections, because they have services like CDN, a caching network for web traffic. You can hook up with direct connect, so you can have a line from your data center to Amazon, and that's on 53 locations worldwide. So they have more points of presence than they have data centers. Zones 1 to 2 milliseconds apart. Regions can be 50, 60 milliseconds or more apart. So you don't spread things on 2 regions, setting up active synchronization and stuff like that, but it tends to mess up. But if you have an application and you want to, or a database you want to duplicate regionally, then you typically do it through the availability zones. Next thing is the foundation services, and I'm not going into detail on all of them because then we would probably spend the whole week. On the left, you have Amazon EC2, which is really the virtual servers. You have something called Lambda, which are just functions you can upload into the cloud, and they typically run for some 100 milliseconds, and you pay just for 100 milliseconds if it runs for 100 milliseconds. Very nice things which can be triggered by events. On the storage side, you have an object store, which might look like an old-style FTP server, where you basically can upload files and you can download them again. You also have a Glacier, which is an archive solution, which costs less, but it takes time to retrieve the data, so it's suitable for archiving large amount of data. You have traditional databases like MySQL, Oracle, SQL Server, stuff like that. You have Amazon Redshift, which is a data warehouse database from Amazon. You have DynamoDB, which is a document database. And you have Elastic Cache, which supports Redis and Memcached, as far as I remember. On the network side, you have Route 53, which is a DNS. Elastic Load Balancing, which we will look into. And more services as well. On top of that, you have queuing service, email service, you have authentication services for mobile, you have transcoding, you have data streaming. They've just released Internet of Things services. They've just also released Elasticsearch, managed Elasticsearch, so you can spin up an Elasticsearch cluster within, I guess it takes 3 to 4 minutes before it's ready, and a lot more, but we won't go into those things right now. As I said, on top of that, you have a management console in the web, and I will show that shortly. Elastic Beanstalk is one way of deploying applications into the cloud and then getting the infrastructure up and running automatically. That's also part of the demo. CloudFormation is Amazon's way of describing the infrastructure. So you can say that you can either make a large JSON file and upload it to the cloud, and then it populates and deploys all your servers, networks, firewalls, and everything. Or if you're setting up servers manually, then you can start an application which does crawls your infrastructure, and then you get a JSON file. So you can take your infrastructure, put it into Git or whatever repository you're using, and then you can use it do it the next week, and then you can just diff it and see if someone has changed anything. Really cool. OpsWorks is Amazon's way of running Chef, the automation tool. CloudWatch is a logging service where you can monitor, retrieve logs and monitor your logs, put up alerts, stuff like that. CloudTrail is auditing. Basically, if you turn on CloudTrail, you will get a log of all API calls to your infrastructure. So you will have an audit log of every changes to your infrastructure, which is quite cool and which is quite hard to do in a data center. IAM, Identity Access Management. And of course, on top of that, since we're talking the cloud, it's not just a management console, but you have an API, so you can automate everything with scripts, program, management tools, stuff like that. And they support a huge range of languages like Java, JavaScript, Python, PHP, .NET, Ruby, Node. They also, on the mobile side, support iOS, Android, and Go. And on IoT, they support C and Arduino Yun. Toolkit for Visual Studio Eclipse and PowerShell. So, DevOps guys, this is something for you, definitely. So, then we've looked into some aspects of the cloud, looked a bit into the Amazon cloud. Let's take a quick look at an example application. I'm just going to use a very simple application today. We could dig into microservices and a lot of fun stuff, but in the example now, I'll just use a basic web server, front-end application kind of thing. We might have an app server as the second tier and maybe a database. So I'll just show you how the console works and how we can start and spin up some servers or launch an application. Let's see if this works. if we're lucky. Yeah, I hope basically you can see this. Now I'm in the Amazon console on the EC2 servers. So if I want to start up a server in Virginia, I will basically just say that I'm going to launch a server, and I'll make the window a bit smaller. You can select what kind of operating system you want to use, whether it's Red Hat, SUSE, Linux, Windows, anything. You choose what kind of server you want to use, how many CPUs you have, how much memory you have, disks, etc. Then you configure a lot of can configure a lot of things like networking, stuff like that. And the cool thing is here is the number of instances you want to start up. So if you want to start just one instance, you do that. If you want to start 10 instances, you just enter 10 and you start 10 instances in parallel. Really takes the same amount of time. You can add storage, etc. I won't go through all that. Basically, launch it. Question?
Yes.
Yeah, is it a quick question?
No, it's a little detailed.
Yeah.
About EBS-backed instances and other ones, some of them can be shut down and some of them can only be terminated.
Yeah.
Why? What's the difference and how we choose?
The question is EBS-backed instances and not, and in general, people are using EBS-backed instances nowadays mostly. The other ones are not used that much, but I don't want to take the details right now. It gets quite detailed. Basically, that's the way you start up a server, and you don't have to go to the shop, and the server is starting up and will be available within a few minutes when you do it like that. The thing we're talking about today is the elasticity, and what I'm going to do now is start up an application stack with. I'm just choosing PHP as an example. The easiest thing is just to press launch now. And then we will get a we'll get a web server up and running, which supports PHP application with Nginx as a proxy front end. And when you want to upload an application to your server, you can just do it through the console, just uploading a zip file, which is quite cool. And I'll show you more details of that later, but this was just an example to show the console and how it works. Were questions or just some?
Can it pull from a Git repo, or do you have to upload a zip file?
Question is if it can pull from the Git repo, or we can upload the file. Just a demo here, I will just upload the file, but there are other ways of doing it. But we can take that in the Q&A later. But basically, this was just to show an example on how to start servers, how to get an environment up and running. And it normally takes 3 to 4 minutes to spin up the infrastructure for the application, because it's setting up networks, configuring the firewalls in the network, launching the servers from scratch, deploying like Nginx and stuff like that. But that's very easy and very convenient, especially when you're working in a project the DevOps way. It's just point and click and launch new applications. But I'll show you a demo application on that later. Back to my example here. Back to the example application. The interesting thing when it's so easy to spin up new servers, throw them away, is how this can influence on the price. And if you're taking this example application, what will it cost to run on premises. 2 servers and a database. For, I'm not talking about a huge application, but say you need some decent servers. Any ideas?
12,000. 12K.
12,000 euros per
For a few servers and a database server.
few servers, database servers. You're talking about investment or running operational cost? Investment. And then you have the operational cost on top of that. And the operational cost is very often hard to figure out on premises because you have a lot of different things you have to sort out there. It's also very hard to scale servers the right way. The normal utilization in a server room is between 20 and 30% if you're good. So a lot of excess capacity. Looking into the example app then, going, let's say we have an application which are used during normal working days. Normal curve, people start getting to job, workload rises, even peaks during the day, and then it slowly goes down. If you're looking into the cost of that on AWS, just an example, we can say that if we are setting up a servers with 15 gigs of RAM and 4 virtual CPUs, it's $44.67 US per week per server to run. And if you're really good, you have found the right server, so you're just managing the peak. But of course, then you have a lot of unused servers during the other times here. So if that's $89 a week. If we're looking at it the alternative way, so we're splitting the big server up into smaller servers, which we can start and stop. We can do that programmatically, remember, through the console. We can make some programs, or we can use other features, making sure that we have enough servers to the capacity. Then we're talking on the medium servers, which are 1/4 of the large. Then you're talking $16 a week per layer instead of 45. So if you're using the flexibility of stopping and starting servers according to capacity, you really save money. On top of that, to be able to do that, we need some load balancing because you're running multiple servers. And the load balancing would probably be perhaps $5 a week. So basically, just by making the application scalable horizontally, you can save a lot of money, more than half the cost of the servers, just by using the scalability in the cloud and making the application smart. Unfortunately, a lot of developers are making applications which doesn't scale horizontally, so we basically have to run big servers all the time, and you don't get the cost savings. So that's one of the big advantages of the cloud here. And I'll show you how it works in the Amazon cloud as well. So let's see how we're doing. On the demo side here, I can show you, I put up an application in there we are. The one we started earlier is now up and running. Basically, it has nothing but a welcome page. If we want to, let's see, upload an application here, we can just upload hello AWS and deploy that into our stack. Then the cloud, now they're checking all the configuration things, uploading the file, and deploying it on the server. That will also take some minutes, but if you're looking into the menu in the upper right hand here, you have a lot of cool configurations as well. You can load and save the configuration of your environment. You can clone your environment. So if you have an application stack up and running for test, and you need a new test environment, you can just clone it, and you will get an identical one. So you can have two test stacks which are identical. You can also swap URLs. So if you're using kind of red-blue deployments, you can launch one stack, and it runs for version 1. Then you put up another stack for version 2, and you just swap version 2 to being production at a later stage when you see it works. And you can upload a lot of application versions here, as I just did with this one. And you can also upload the applications without putting it on the servers, and then you can just say, deploy it now. So, and it can also be done programmatically. They have command line interfaces for doing all of this stuff. Now that's up and running, and hopefully we have the new application there as well, which basically just says the IP address of the server. I just want to take a quick look at the 12-factor app. How many here has heard about the 12-factor app? Some. Check it out. It says what you should do and should not do when you're building applications which are going to be scalable. I'll just go through some of it, not all the details. It's a methodology for building software as a service applications. And basically, there we are. Use declarative formats, have a clean contract with the underlying operating system, suitable for deployment on modern cloud platform, minimize divergence between deployment and production, and scale without significant changes to tooling, etc. They have 12 points which you can look into. It's not very big. It's a few pages on each of them. For example, it says that on the configuration, you should never store your configuration within the application. You should store it somewhere else, so your application is working regardless of where you're deploying it. It says something about backing services. So when you're kind of building microservices, you don't really care whether you're talking to the database or you're talking to Twitter or whatever. It's just a service you're talking to. Processes are stateless. So you're trying to make a stateless application, because then you can scale horizontally and you can just throw away the servers when you don't need them anymore. So you don't have people sticking onto one server for a long time, because it's hard to throw away the servers, and it's also hard to load balance in that way. If it's stateless, you can really send people to whatever servers that has capacity. Concurrency, processes are first-class citizens in that. So basically you want to distribute the different layers with different number of service or processes regardless of the application. And disposability. So when you don't need a process anymore and you want to scale down, you should really just kill it, throw it away. And it should be fairly quick and not a long, huge cleanup process. That was just a few brief things about the 12-factor application and the list. And as I said, look it up on the internet. It's a really good guideline out there. we looked briefly into our example app earlier, and we were just setting up one server. I didn't set up the middle tier or the database in this example. It would have been pretty easy to do that. But what we really want to achieve, as well as setting up several servers, is getting it redundant. Having multiple servers in the same data center is kind of wasteless if the data center goes down. And it can go down in the cloud as well. Both Amazon and Microsoft have had cases where they have problems with one of their availability zones. So what you really want to do when you're starting up several servers is to start it up in different availability zones. And that's pretty easy in Amazon. You have the load balancer, and basically you tell the load balancer when you're setting it up that it should distribute load to the different availability zones. And you have something called autoscaling. And autoscaling is a service which looks at your servers, looking at the metrics, and see if you need to scale up or down. So you can tell it to scale based on CPU, network traffic, latency, error rates, whatever. And you didn't see it, but in the application I started recently, that was deployed with load balancing and autoscaling, even though it was just one server. In addition to that, if you're going to put this in production, you really have to look into network configuration. You have to look into firewall rules, DNS, all that stuff. But it's pretty easy, pretty quick, pretty straightforward if you know something about infrastructure. So back to our example app. Looks something like that without a database. I didn't set up that. And if you now look at the price we discussed earlier with running it on-prem, running just one server for $90 a week, $89 a week, or reducing it to half. So by reducing the cost to half, you have also added geo-redundancy, which is pretty cool and which is hard to do and very expensive if you're running on premises. So what I think we should spend some time on now is looking into the scalability here and how it works, because then you can see it. So now we'll look at the details I didn't show you earlier. Turn mirroring on, switch screen, and switch console. I started a demo application earlier in Ireland. Reason I started it is for the demo to be effective, I have to turn on some of the health checks and all other parameters here. Otherwise, it will take time to change the environment because it doesn't scale up and down. Normally, you don't want to scale up and down within minutes when you're running. You want to scale up quickly, and you want to wait with scaling down, let's say, within half an hour or an hour. So here are 3 windows running our application. Basically, it is the IP address and the date. So you see that it reloads, and you also see what the IP address of the server is. Now I'm running just one server. And what we're going to do now, it's one server in one zone. And what we're going to do now is say that, okay, the CTO says that we need to have 3 servers in 3 availability zones in case something happens. And we need to be able to double that if the traffic rises. So the way we do that is basically go into the configuration here. Says I want to change the auto scaling to 3 with a minimum 6, minimum 3, maximum 6 servers. The scaling here is triggered by the CPU utilization. So I'm saying that if I have an upper threshold of 70%, then I will add a new server. And if the CPU utilization falls below 50%, then I will take away a server. But you can scale on network in, network out, disk latency, request count, whatever almost. And you can also write your own alarms and triggers. A recently added feature is you can also scale on timing. So if you know that you need a lot of servers daytime but not nighttime, you can put it like a cron job, which starts and stops the servers. Basically, I changed from apply. I changed it from 1 to 3. If you're looking into the console on the servers, I have just one server running as we speak. And now it takes the configuration, it changes the load, it changes the auto scaling, which is a service that monitors how many servers are running and how it should scale. So when it's done configuring that, the autoscaler will see that we have too few servers, and it will start servers, add them to the load balancer, and we're up and running with 3 servers. 2 servers are starting. Takes a few minutes to start them. And then we will have 1 server in EU West 1, which is Dublin. A is availability zone A. We will have EU West 1B, and we have one in EU West 1C. One is running. Next one is coming up. It gets detailed here. Right now, we have the load balancer only knowing about 1 server, but it has to come up and running, and it has to see that it's up and running, and it will be added to the load balancer as well, eventually. And hopefully, we will see different IP addresses later on those screens. So I made the IP addresses, so I have a 1, 2, or 3 there, depending on the availability zone. Running. Three servers in the load balancer, and 1 in service, and 2 is out of service. And the load balancer is checking the health of the servers. So I've just said I check the root, see if you get a 200 OK, and you have to get a 200 OK twice and checking every 5 seconds before the server is OK. If it fails 1 time, it doesn't matter. If it fails twice, then it says that the server has failed and removes it from the load balancer.
What does it check the health on? So is there a standard endpoint? Or?
I've just told it to check on port 80 on the root to see if it gets a 200 return, and OK. And as you can see now, the 3 windows are hitting 3 different servers.
This simple app uses more than 70% of CPU utilization.
The question was if I used more than 70% of the CPU utilization. No, it doesn't. I said to have a minimum of 3 servers. So it started up 3. If I were to go above 70%, then it would start another one, and then another one, until we reached 6. It's a bit more messy to show that, because yeah, you have to write an application and wait for the CPU to become about 70, etc. But it shows how easy it is to set up a geo-redundant, scalable web application. And you can deploy with this stack with the various of languages. And you can also configure the Nginx, which is in front here. And they also deploy a I don't remember the tool, but on the actual Linux servers, they deploy a tool which monitor the process. So if you kill the Tomcat process, or if you kill some other, if you're running Java, kill the Tomcat process, it will restart.
Yeah.
So now we're hitting 3 different servers, and if, let's say we're going into the console and we just want to, we're just doing like this, just terminate, kill. We're just killing a server.
Wouldn't it recreate it?
So basically now the load balancer has already detected that the server has a shutdown signal, so it removed it from the load balancer so you don't get traffic to the server which has died. 2 of them died because they were just reloading while you were working here, obviously. And in a few minutes time you will see a new server being created here, because we said we will have to have a minimum of 3. So it will detect that. And go ask the old IT department to set up a solution like that, and ask how much it is and how quick they can do it. So I think that's really cool. If we want to change the server, let's say we say that the server we are running now, which is a T2 micro, which is quite small, we want to something with more memory. We do it exactly the same way. We go in the console, just saying that we need a medium server. Then it will start up medium servers and kill the micro servers. And you will just, while the application is running, without downtime. So now it's starting up a new one. And as you can see, another cool thing is it starts up in 1A. And the autoscaler is made so that it tries to distribute the servers equally in all availability zones. So it doesn't start up 3 servers at the same place. And if it has to shut down the servers, it shut down the servers who's been running for the longest period within an hour. Because if you shut down a server which has been running for 5 minutes, you're paying by the hour. That's waste of money. So you take the server which has been running for 50 minutes instead. So I'll just go quickly back to my slides.
Can you show the server upgrade one, as you said, for example, from the micro to the medium one?
We can look at how we can configure this later in the Q&A session, if that's okay. So basically, I'll just go briefly through. So we looked at how we could do this now with the servers and the elasticity. There are a lot of other ways to do it as well. This was just one example using the Beanstalk from AWS. You can do it by using those components. You can build scripts. You can use, we have some customers using Jenkins to stop and start servers, for example, based on cron jobs, based on need when you're running builds, and so on. Just wanted to, for those of you who are not used to AWS, just put a few words around auditing and control on the cloud here. Getting access to the infrastructure, stopping and starting servers, configuring network and so on is very good controlled by policies in Amazon. So we can basically say that one user have access to start a server only if it's from a dedicated IP, only if it's through, the call is through HTTPS on Monday to Friday between 9 and 4, for example. And you can do that with all the API calls, so you can have a really good control on who's doing what in your infrastructure. Also on the routing, firewalls, etc., it's the same fine-grained control. I mentioned CloudFormation earlier, documented infrastructure all the time, so we have infrastructure up and running. That can be extracted as a JSON file. So you can show it to the auditors. This is what our infrastructure looks like right now. CloudTrail. If something has changed in the infrastructure, you will see it in CloudTrail, and you will see who did it and what they did, and you will also have the raw data from the API call. You can also put up an alarm on a lot of events, both on the servers, but also on the billing side. You have something called AWS config, where you can see the configuration in the console on how the infrastructure is now, but also how it looked before you changed it. So we have a good management on that. And you have a new service called Inspector, where you can launch an agent on your server which checks for if you've done something bad regarding the operating system, the network, the application, and so on. Just an example on policies. All policies can be written as, or has to be written as JSON files, so we can really use tools to check that as well, and also check it in the version control system. So if you have a new application which needs new accesses, you can also put those access lists in your version control system with the same thing. CloudFormation, I mentioned that. That's the description on how to start a virtual server. You're starting a server and you're installing Puppet when it's booted. And if you're giving it the right host name or something like that, it bootstraps itself without you having to log into it. CloudTrail, I mentioned. This is an extraction from CloudTrail. So you can see I have been doing something with the instances and the security groups. So security is, from my point of view, extremely good. And one thing is, it's good to know that when you're using AWS, but you should really think about it when you're building an application and see how the AWS guys have built the security into all their endpoints with all the logging and the fine-grained control, because there's a lot to learn on how they've done it. And if you're running your application on top of AWS as well, you can use a lot of the services and the APIs there for getting the same information from your application as you're getting from the infrastructure. So, just to summarize before we take a Q&A, if you're going to use infrastructure as a service cloud, know your responsibility. As I said, you're responsible for the operating system, you're responsible for all the security regarding your application and so on. You can't blame anyone else. The providers will take care of the virtualization and all the other bits and pieces. Forklifting an application into the cloud will work, but as I said, it's much better looking into the 12-factor app and similar ways of doing it. Use the tools provided to get things done. There's a lot of tools in AWS, and there's a lot of tools built on top of that, which is not provided by Amazon, but you can use to leverage the cloud. And economies of scale is here now. So if you're interested, what should you do? Just create an account. There is a free tier, so you get some services for free for the first year. A lot of the services here are quite cheap. So like my employer pay my AWS bill, and we pay the bills for all our consultants who wants to have an account with AWS. And we're using several dollars a month on this. It's really cheap, and it's really good to get people to work on it and learn how to do it. And it's much, much, much cheaper than people running off buying an extra laptop, buying some more disk, buying a server, networking, routing, whatever. So creating an account, hop onto the free tier, use the web APIs, play with it, learn it. Yeah, identify your possibilities and explore the cloud. That was basically what I was going to say during approximately 1 hour, which I think we hit more or less. And I know there are some questions here. So let's open up for questions. And we can also look more into the demo, which is running as well. So we can take that as a first question. How do you switch from a small server to a large server in that setup?
Well, I have a bunch of other questions.
Yeah, sure. I think we'll get some help with facilitating the questions here because we have some online people as well. Switch monitoring on. And there we are. We see that the microserver is not good. Now we're running PHP now. The application is growing and it needs more RAM, for example. So basically what we do is saying that we're going up to M3 medium server, which is bigger than the microserver. So I just change it to M3 medium. And that's it.
From which screen you do this?
Configuration.
I know, the Beanstalk.
In Beanstalk. Save. And then it starts working on it. That's it.
Copy the data and everything from the previous server to the new one.
Questions about copying data from the previous servers to the new one and so on. What we're doing now is we're treating the servers like cattle, not like pets. So we're just throwing them away. Don't keep data on the servers. Never, ever. Either you keep it in a database or a data store or somewhere else. The servers, you just want to throw them away when they're sick, when you don't need them, and you bootstrap them from scratch every time. In that way, it's also easy to have a very clean server. Of course, you can bootstrap it from an image which has been patched, or you patch it when you bootstrap it. But my recommendation is to keep it as clean as possible. And if you're storing data on the servers, then you're really not going to make this work. So keep it somewhere else. There is another question. Now I'll just show you that Amazon is working for us while we're speaking. It's starting up a new medium server. And it's starting up a medium server before it stops the others. Because we've said that we need a minimum of 3 servers, so it doesn't kill one and start one. It starts one extra and then it starts killing the others. More questions? Yes?
Yes. Before we've seen how to scale horizontally, and then you showed us how to upgrade one instance from a small one to a medium one. Is it possible / is it advisable to scale vertically, to put some auto-scaling also vertically, so automatically switch from a small to a medium instance?
Question is if we can auto-scale vertically. And I'm not sure if I'm seeing the use case right there, because you can have an autoscaler on the different levels. So if you have a web server and an application server, you will have an autoscaler on the web layer and an autoscaler on the application layer, so they will scale independently horizontally in each layer. I don't see how, you don't want to scale, build more layers, or did I misunderstand you?
No, actually that was the question, if it makes sense to do that.
Yeah, it makes sense. Put an autoscaler on all the layers, that makes sense. Even if you're just running one server, it's nice to have an autoscaler. Because if you're having some dodgy application which just takes down the server, it will come up again automatically. And if you have a load balancer in front, you don't have to think about the server's IP either.
About the Git question.
The Git question. If you can deploy from Git, for instance, there are, yes, you can. There in Beanstalk, I don't think you can do it just right out of the box, as I said, but there are ways to do it. But you also have something called code deploy in Amazon, where basically you can deploy to your server farms when you have committed something in GitHub, for example. and it's integrated with GitHub, and you can also integrate it with your own repos and things like that. So it's doable. This was just an example. And sometimes you also want to, if you're just committing single commits and pulling that into your application and starting it up, that's one way of doing it. Another way of doing it, if you have a CI system, so you want to run some checks before you're making an application, and normally you would pack the application, put it someplace, and then bootstrap your environment from there. But yeah, there's a lot of ways to do this, and on YouTube you will see a lot of talks from reInvent, from Amazon's conference, on deployment in various ways. There is not a wrong way or a right way. It's your way, basically. Question in the back.
Yeah, I know there's a Python library for API into the services that AWS provides. I think it's called Boto. Do you know what other languages they have libraries for, and what's the most robust?
Questions about API support on languages, and I think we covered that briefly earlier. I'll just get back to my slide on that. It was in the beginning here, so with a lot of other information. There you have the languages on top there. So it's Java, JavaScript, Python, PHP, Net, Ruby, Node.js.
I know that the Python has variances into what is available that you can API, and do all of them have the same limits?
Question is if there are limits on the various APIs on what they're supporting. I've not used them extensively. They are at least the most popular ones, like Java, JavaScript, and PHP, I guess, is more or less up to date. The Python I haven't used much, but there are also the people making SDKs on top of that, of course. So you really have to look into it. I don't know the details, but services are coming so fast, and Amazon is trying to launch the APIs to support it. Also, there are two levels of, not on APIs, but command line interfaces here, because if you're like sitting on Linux, you can also install a command line interface, so you can just write AWS easy to start instance, blah, blah, blah. But you also have separate command line interfaces for different services. So like for Elastic Beanstalk, you can also download a command line interface just for Elastic Beanstalk, so you can do a lot of details there.
So you're talking about also security. I mean, especially about cloud is also scalability. So what's about load management, preventing DDoS, or doing something against there? How can AWS help me there?
Yeah, question is on security and how AWS can help you on like DDoS and other nasty things. When it comes to DDoSing, that's normally not a huge problem on the AWS servers because of their backbone infrastructure and the way it's built. And it also depends a bit on how you're building your system. Of course, it's possible to do trying just to hit your server to download an image a million times or something like that. If you have a web server, normally you would put the Amazon CDN in front, which is the content delivery network, which is in 53 locations. So depending on where you are, in what region you are, you will get a different IP and a different endpoint, and they're monitoring that for DDoS attacks. It's the same way Route 53 has been built, so they're recommending using the CDN in front of all web traffic. And also, if you have public APIs and stuff like that, you will also get caching there for things that can be cached, and it can also, in a lot of cases, save you some money on bandwidth and outbound traffic by doing that. On the if you're having APIs, you're you're exposing. They have an API gateway you can use, and there you can put up throttling. So you can say that you just want 100 requests per second, and then you start throttling, at least so you don't kill your servers back there. But there are various ways of doing it, and they also have detailed recommendation on a lot of that. But the CDN is the best part, especially when it comes to DDoSing, and of course also monitoring your server. The good thing about treat your servers as cattle, not as pets, is that if you see that you have unexpected traffic on one server, then basically just spinning up a new one and shutting down the old one as well will help, because it's changing IP and it's changing the whole picture. Same when it comes to security and people trying to break into your servers. If you are relaunching your servers once a week, you know, it's very hard to break into them because it takes time for people to break into them. So it tends to, at least for what you read on the net, it tends to be that people are targeting other sites than the ones running in AWS and Azure. What you should be careful about is where you put your credentials, so nobody don't get them and start spinning up servers in your account, which has happened because people were storing the credentials in their code, pushing it to GitHub, and then all the Bitcoin mining people got hold of it, which is not very smart. There's a lot of recommendations on how you should deal with that within AWS. If you're running only on AWS and you have applications which need to access the infrastructure, you really shouldn't have to deal with credentials at all, because you can give the server a role. So you can have a management server which has a role as a management server, and it's allowed to start and stop other servers. So they have an automatic key rotation every second hour and stuff like that underneath if you're using the SDK, which is really cool. One more question?
In fact, it's two. One of them is that here what we do is to put the beanstalk in the top of the EC2. But however, what if we have EC2 and, for example, at the moment we run two servers and we want to add auto-scaling to them? How we can customize the auto-scaling, and how to keep one server as a manager server, for example, not to kill in any scenario, but others.
Question was about auto-scaling and if you can set it up manually. Yes, you can. It's let us see where we are now, just making sure all the medium servers are up and running. Going into the load balancer and the auto-scaling group. So you can set up the auto-scaler manually here in the console, or you can program it. So when you're using the beanstalk, it just does it automatically for you, and the configuration in the beanstalk is just pushed into the autoscaler. So the autoscaler is really your atom. You know, you have the load balancer, you have the autoscaler, you have those things, putting it together in beanstalk. If you have a server you don't want to kill, you can't put that in the autoscaler. It will be killed. Can be killed. But really, you should expect that a server can die. Basically, if you have a server like we have call it a management server or whatever, then you're storing the data on a disk separately. So if the server dies, you have all the data and you're spinning up a new server, just attaching the disk, just like having a USB drive, plugging it in. That's the way you should do it. But again, that's the data, then it's stored outside the server. More questions? You had more questions, yeah?
At first you said that there is a difference between Microsoft Azure and AWS.
Yep.
Can you name some of them? Because I worked with both of them.
Question is about the difference between Azure and AWS. Just first of all, to take all the details, go onto YouTube, Google, and now search on reInvent Gartner Group, AWS Azure, and you get a talk from Gartner Group about the differences. There are technical differences and there are other differences when it comes to support, what kind of support Microsoft is giving to customers versus Amazon. On the technical side, what I see with clients who is getting there, looking into what IaaS provider to use. If they're getting down to looking at Microsoft or Amazon, it's good because then we can look at facts. If they're talking about wanting to use VMware versus Amazon, then you're talking more about feelings because they have some relation with VMware, so it's hard to discuss. Microsoft is very Microsoft-centric. So if you're only using Microsoft stuff, Azure might be good for you. If you're only running a lot of Linux on open source stuff, it's probably much easier to use the Amazon cloud. If you're running, want to run Elasticatch managed, you have to go for Amazon. If you want to have MySQL, MariaDB, Postgres, Oracle managed, you will go to Amazon because Microsoft don't have them. And when it comes to the security and how fine-grained it is, it's more fine-grained on Amazon than on the Azure. And a lot of other details around that, some details around networking, billing, etc. I know you have more questions. Are there others that have questions?
It was just about this question. You mean by security the user securities, user groups, or the whole application security as DDoS attacks or others?
When I'm talking about this related to security and the things I just said is how you can control the security on who can get access to the different APIs. In Amazon, as I said, it can be as fine-grained as saying you have access to one operations only in that time frame, only if you're connecting through HTTPS with a multi-factor authentication, blah, 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 blah. In Azure, it's larger bulks, more like you have on Windows where you have people can be in a group and read only, write only, things like that. So it's larger collections of that. Yes?
When I'm storing my credentials on GitHub in an encrypted file, then that's obviously my problem. But have there been in the past incidents where it was basically Amazon's fault that, I don't know, data got leaked or accessed that shouldn't have been accessed?
Question is if there has been any incidents with leakage from the AWS cloud. Honestly, I have not heard of any serious incidents there. It's basically wrong usage of the services. That goes for Microsoft as well on the IaaS side. People tend to blame the providers, but then again, when you look into it, they've done something they shouldn't do. Something easy like have an account, they have their account into the cloud and they have not turned on multi-factor authentication on their root account, for example, which is strongly recommended. Or they're opening too many ports or whatever.
Quick question. Again, for Beanstalk, I don't know if it's relevant for Beanstalk, but a lot of times when you have an application and you deploy, you'll want to have some kind of a script to be triggered, say to download packages. So you've got Composer or whatnot. Is there a way to configure that in Beanstalk to say, here's the source code, put it up to the server, and then run a specific command or script?
Yeah, question is if you can run a specific command or script in Beanstalk or in other ways when you're bootstrapping a server. Thing is whether you want it to run it before or after you launch the application. You can easily run a script or run commands when you're launching a server regardless of the application. You can put it in through the console, or you can use it through the API or the JSON file. So yeah, and it's run only when the server is instant.
I'm asking because of the scaling. Normally, say what I will do is I do an AMI image.
Yep.
And then set everything up, do a snapshot, and use that for my scaling. But with Beanstalk, I'm assuming you'll give it the source code, and then it will control scale up and scale down.
It will scale up and scale down.
When it scales up a new instance, is there a way to configure it so that you tell it, okay, you scaled up, you have the source code, but now you need to run these scripts to set up the environment?
Yeah, you want to run a script after you have uploaded the application, basically. Yeah.
Can you automate it?
If you can automate it in Beanstalk, I think it depends on, might depend on the application you're using. You can, to some extent, automate things in Beanstalk. What you also could do, if you're just, you could also skip Beanstalk and just make an image in Autoscaler, so you don't use, you make your own image, like you would with the application, and then you're just cloning that image for each server. So you don't have to use Beanstalk.
Okay, so you're not forced to provide it a zip file, you can just...
Yeah, in Beanstalk on the PHP, you have to provide it a zip file. So if you're doing it that way, it's harder to automate it. But if you have some specific things you would like to do, there are ways of getting around it. And you have, Beanstalk is just one way of doing it. You have like Chef, you can automate. You can bake an image, as they're saying. You're setting up one server with the application and stuff, making an image. So each time you spin up a new one, you're doing it from your specific image, not from a generic image. That's another way of doing it. Yeah. So there are ways of doing it, but I really have to dig into it because my gut feeling says that, yes, it's possible, but it requires some tweaks in there. Beanstalk is really made just to be lightweight on the deployment there. So your use case isn't quite suitable for Beanstalk, perhaps. But if you can, yeah, at least if you have to run it after you've deployed the application.
I have a question related. Is there any kind of approaches to provide a framework like this as a product or open source software?
Provide a framework for?
Yeah, like the Amazon Web Services.
Yeah.
So you can, of course, you need some kind of data center where you can deploy this framework.
I'm not quite sure what you're referring to now. There are, if you have a data center in general and want to deploy your own cloud,
yes,
private cloud in your data center.
To set up a private cloud.
Yeah, there are frameworks and also tools and software to do that, like OpenStack and others.
Mm-hmm.
It's quite tough to get it up and running properly.
Mm-hmm.
And you would really need a lot of servers if it is going to be scalable. Yeah. And the latest news is that HP is kind of giving up the whole cloud thing because they have a hard time setting up cloud infrastructure. And that's not because they're stupid people. It's just because it's very, very, very hard and expensive to keep up with the big guys here. So basically what tends to happen if you're setting up and want to set up your own private cloud is that you're ending up with some automated virtualization and not the cloud, which is maybe what you want. Because if you're looking into the cloud and all the different services they have here, then you will have a really tough time doing it in your own data center. But there are
only this product by HP.
There are products around, open source products, and also products by different vendors, which you can buy or download for free and whatever. And I'm sure the hardware vendors will be happy to sell you a lot of servers to set it up. But really look into what you need. Do you really need just automated virtualization so the DevOps guys can order new servers, or do you need all this other cloud-wise infrastructure with accounting and billing and queuing and auto-scaling and all that stuff, which is on top of that, which very, very few are able to set up efficiently. But it's possible. People are doing it. I know people are doing it. And so OpenStack, for instance, Red Hat have products around it. HP, VMware, yeah, you name it.
Okay.
Was that an answer to your question?
Yeah. Just was wondering if anyone tried to do it separately of some own cloud.
A lot of people have tried to put up their own cloud, and a lot of people have failed as well. If there are not, yeah, we have one more question, and I'll stick around after this as well for some minutes if people want to discuss individually.
Actually, I have a question. What's a good reason to not use AWS? I mean,
what's the reason not to use AWS? I have some reasons for not using AWS, which might be obvious for some. One thing is if you have a really old, hard-fashioned legacy system which is hard to lift into the cloud. You know, there are applications which will be really tough moving into the cloud because it won't work. They're running on Windows NT kind of things, stuff like that. If you might have some regulations and rules, like in Norway, I don't think anyone working within the health companies, health industry, doctors, hospitals, things like that can use the cloud. Financial sector is in some countries very hard to use the cloud because you have local legislation saying that some data should be within your country. You're not allowed to put it in a data center where you cannot have a physical inspection, for example, things like that. So there are cases, but like I guess for most people, it should be possible to use the cloud, and the security argument is not longer valid for most of the cases.
It seems like because Amazon has no German legal, institution. I mean, there's no Amazon Germany, right? It seems to be kind of regulatory problem for some. The question around Amazon and Germany, I guess it goes for the same. I don't know if they have a registered office in Germany. They have an office in Berlin as well. I was there today. When it comes to the data here, again, if you're looking for a lot of purposes, it's infrastructure as a service. So if you want to encrypt all the disks on your servers, if you want to crypt all the data in your database, all the communication between the servers and things like that, that's your business, you can do it, and they can't look into it. So if you're afraid of like NSA and stuff like that, you should be pretty safe. But there are some things you can't really protect against, but then I think putting it in other data centers would be more unsecure. One question there, because so when we were looking into this, there was the point that AWS couldn't guarantee that the data stays actually in the specific region, as they do backups. Because if, for example, if the whole region dies, why? I don't know.
Yeah.
Meteor coming down.
Yeah.
And that they're actually doing backups to other regions which you cannot control.
Question about moving data between regions and availability zones and things like that. It sounded like a strange answer to me because they have a lot of certifications and approvals that are not moving data around on the different services. So if you're using a compute service, if you're using a storage service, things like that, it stays in the region. It does. Some services are floating around, like the CDN, like the DNS, but it has to do that. But they're not moving data around. So if a meteor hits Frankfurt and you don't have anything in Ireland, then you're gone. But then you probably have other problems as well. But the reason I think they built a data center in Frankfurt was just because of German law that is quite strong. So people are trusting that, putting it there. And then you also have redundancy with Ireland. So
we're still seeing a lot of assumptions around that they do not trust
yeah.
Amazon for sure, because Patriot Act, Freedom Act, however you want to call it.
Yeah. Patriot Act, Freedom Act, and all that stuff. My suggestion is if you want to use AWS and you're getting into those discussions, get in touch with someone at AWS, because you can get a lot of documentation under a non-disclosure agreement to look into on that. But
like when they have a infrastructure which is, for example, PCI compliant, which is quite strong. You know, you have to comply to a lot of things if you're running credit card transaction on it, and there are a lot like health compliance in the US, lots of other stuff. So I trust them, and it's done by third-party auditors. And the latest they have is the ISO 27018, which goes on personal data and stuff like that, I guess. So there's a stack, and it's the same from Microsoft. They have the same stack almost.
Okay, I think that was it. So thank you very much.